Hello, and welcome to our first virtual online lesson. Although, if you've watched any of them from the YouTube channel, you are used to this kind of idea. We are doing a review this week on the real number system. If you have a printer, Miss Henry and I, have provided this lesson sheet that you see here on my screen as a PDF for you to print off and follow along with as we do our notes here. If you do not have a printer, you are welcome to take out a sheet of notebook paper and jot down some notes as you go along. You are going to want to make sure you are taking notes, whether it is on the PDF that you've printed off or your own notebook paper. You're going to want some notes to help you for when you need to go and do your assignment after this. So let's look at classifying real numbers. So A here says positive counting numbers that start with 1. So if we start counting 1, 2, 3, 4, 5, 6, what kind of numbers are those called? It's been a little while, but if you don't remember, we are going to help you here. They are called natural numbers. I like to think of those as numbers we naturally count by. Okay, the next one, positive counting numbers starting with 0. So this time, 0, 1, 2, 3, 4, 5, and so forth. Those are going to be our whole numbers. And I probably should also, actually, you know what I think I'm going to do? Is I'm going to make this box red. And if you have some colors, maybe you can pause this and you can kind of color code this as you go along if you like, just a suggestion. And so that means the most limited or smaller group of numbers are the natural numbers, and then we have our whole numbers we just said, and that would be this box right here. These are our whole numbers. Our whole numbers also include the natural numbers, because if we start with 0 and then go 1, 2, 3, 4, and so forth, we're also including the natural numbers when we say those. Okay, the next one, C, whole numbers and their opposites. So, for example, 1, 2, 3, 4, and -1, -2, -3, -4. Those numbers are called integers. That's our integer. That's an integer. I'm going to go up here and I am going to box this in with green. So integers include the whole numbers. They include the natural numbers. Okay. And then we have fractions. D would be our fractions, our repeating decimals and terminating decimals. Those are called our rational numbers. And so that would be all of the numbers that we've already talked about, including fractions and decimals. And then we have our irrational numbers. So our irrational numbers are the non-terminating or non-repeating decimals and non-perfect squares. And those are going to be these numbers over here. So basically, numbers are either going to be rational or irrational. And then if they're rational, then they can be more specifically an integer, a whole number, or a natural number. Okay, let's look over here at square roots. So just as a reminder, this little radical sign, a number means what number times the square root is a number times itself. We'll give you the number inside the square root. Let's see here. Estimate non-perfect squares by using a number line. Okay. And then the third little bullet point here says, for example. Okay, so if we're going to estimate non-perfect square numbers by using a a number line, that's this next part. Let me go up here real quick. So for example, on this one, the square root of 36 would be 6 because 6 times 6 is 36. Another one might be the square root of 100 would be 10 because 10 times 10 is 100. Well, if, for example, we had something like the square root of 80 that you see here, we don't know a number times itself that's 80. So we have to find the two closest perfect squares that we do know, which would be 8 times 8, which is 64, and 9 times 9, which is 81. And so the number line above shows that it would be a little bit less than 9. Right here should be the square root of 80, right there. And so we could say that it's a little less than 9, so it's probably about 8.9. Now, if you wanted to double check that, you could do 8.9 multiplied by 8.9 and see what it comes out to, and it should be really, really close to 81. All right, if we're given the area of a square, meaning the whole area, all of this, the side length of the square, meaning if we just needed to know what the length of one of the sides would be, we can find that by taking the square root of the area. So for example, if I gave you a square and I said that the area was 49, and I said, well, what is the length of one of the sides of the square? Well, we know that both of those have to be the same because if it's a square, it's the same length all the way around. So it would have to be 7 times 7, which means that one of the sides of the square would be 7. All right, let's look now at the fractions to decimals, just as a good little practice here to remind us how to do this. Okay, so going from a fraction to a decimal, it's been a little while, but you probably remember that we need to chop down the tree. Okay, now what that means is when we chop down the tree is we have to make the tree fall over, and that's just a helpful way of reminding us that the numerator, which is the number up top, is going to fall down into the division symbol, and then the 9 is out here. So if it falls to the right, that helps us remember that the numerator goes inside. So now we need to divide this. So when we divide this, 9 cannot go into 2. So we're going to put a 0 and a decimal. We're going to add another 0 here. And then we're going to figure out how many 9s can go into 20. Well, you should come up with 2. 9 times 2 would be 18. And then we subtract. 20 minus 18 is 2. Well, we still have that remainder, so we add another 0, bring it down. And here we are still trying to make 9 divide into 20 again, and that's going to just keep giving us a 2. So that 2 is repeating. So the way we write our answer is like this, 0.2 with a line over the 2. That shows that it is repeating. Okay? All right. Let's try the next one. Okay? So we are going to try to make sure I have enough room here. And if you've got your own paper, or maybe you can just write a little bit smaller. We've got 13 inside and 99 outside. So 99 cannot divide into 13, so we add a decimal and a 0. 99 can go into 130 one time. That gives us 99. So 130 subtract 99 would be 31. And since we have that remainder, we're going to drop down another 0. 99 into 310 is going to go 3 times because 99 is almost 100. So 99 times 3, 9 times 3 is 27. Whoops, I did that wrong. Carry the 2, and then 27 again, plus 2 is 29. Subtract. Let's see, we got to borrow again, so we end up with 13. Okay, so we add another 0, bring it down, and again we're going into 130. So that's kind of like where we started, where we're going to end up having another 1 and then a 3. So it's going to just keep repeating 1 3 1 3. So since the 1 and the 3 are both repeating, we're going to put the line over both of those. Okay, if you're feeling pretty good, I would suggest that maybe as some practice, you pause this and try these next two and then start it back up. Okay, if you paused this, let's see how you did here. So we've got 40 divided by 33. 33 can't go into 4, but it can go into 40. Gives us 33. 7 left over, bring down the 0. 33 and 33 would be 66, so it looks like it could go twice. That leaves us with 4, bringing down another 0, and we're going into 40 again. So it looks like it's just going to keep repeating the 1, 2. So we put the line over the 12. Okay. All right, now 1/3. 1 divided by 11. So 11 can't go into 1, so we do this. Now 11 can't go into 10, so we're going to have to put a 0 and add another 0. How many 11s can go into 100? 9. That will give us 99 with 1 left over. We add a 0, bring it down, and here we are. 11 into 10, can't do that. And that's what we started with, so it looks like the 0.09 is repeating this time. Okay, decimals to fractions. All right, so 0.4 repeating. So when we have repeating decimals, we are going to use 9s in our denominator. So let me just kind of backtrack for just a minute. I'm going to go over here to the side, and let's say we just had this, no repeat. It was just 0.4. Well, that would be, as a fraction, that is a 4, and it is in the tenths place. So 4/10 would be the equivalent fraction. Now, you could divide them both by 2, and you could simplify this down to 2/5, and that would be fine. But we use 10, or if this was 0.40, sorry, that's sloppy, 2, then it would be 42 over, this is the, goes out to the hundredths place, would be over 100. Or if it was 0.425, then it would be 425 over 10 hundredths thousandths place. So see how the denominators are going, 10, 100, 1,000. Well, that's what we do for these. But if we have a repeating decimal, we're going to use 9 and then 99 and then 999. So it's really actually that simple. So we have a 4, and it's just, there's just one place value there, so it's going to be 9, 4/9, and that doesn't simplify. Okay, the next one, and I'm going to have to write down below because I'm running out of room, 47 over, and there's 2 places, so it's going to be 99. You need to stop and think if you can reduce it. You should, but doesn't look like it's going to reduce. All right, the next one is going to be 15 over, how many 9s? 2 of them. 99. Now this one does reduce. What can go into both of these? 3. So we're going to divide them both by 3. 15 divided by 3 is 5. 99 divided by 3 is 33. So 5 over 33 would be the fraction for 0.15 repeating. All right, and then this one is 54 over, there's 2 of them, so 99. And that can also divide by 3. Do you know what 54 divided by 3 would be? We're not really using our calculator here on this one, so you might need to kind of go out to the side and do 54 divided by 3. 3 goes into 5 once. 5 minus 3 is 2. Bring down the 4. And 3 goes into 24 8 times. That will zero out. And so it's 18. And then what would 99 divided by 3 be? 33. Oh, you know what? There was a bigger number that we could have divided those both by. 9 could have gone into 99, and 9 could have gone into 54. But that's okay. We're just going to divide this by 3 again. Should have caught that from the beginning. And we are going to get 6 over 11. So had we started out from right here and divided both by 9, 9 goes into 54 6 times and into 99 11, and we would have been done. I'm sorry about that, but that certainly did not hurt us. All right, and then the last part, when we are ordering numbers, we put numbers in the same form first. So if we have a list of numbers, you're going to want to put them either all into decimals, all into percentage, or all into fractions will be basically your easiest way to put them in order. So this just says, for example, convert numbers to decimals before ordering. So I would suggest that it's just a little easier if you put them all into decimals first. And so least to greatest means, if you're going least to greatest, that means you're putting the numbers in order, in increasing order would be one way to say that, increasing. Or another word that they could use to ask you to put them in order from least to greatest would be to say in ascending order. Okay, and then greatest to least would be decreasing or descending. Okay. Now, it really, I just noticed that even though we just discussed putting numbers in order, we didn't really practice that in particular. We did practice writing fractions to decimals and decimals to fractions. And we don't have any percentages, I guess. There is a really cool app that would be worth your time. It is called the Numberline app. It's really, really cool if you happen to have a device where you can go. I believe it's free, and it's really neat. It helps you put numbers in order. It does have decimals, percentages, and fractions. And I don't think that I have it on this particular iPad, actually. I'm not sure if I've downloaded it on here, or I would show you. But it's pretty cool. If you want more information, just contact your teacher about that, either Miss Henry or myself, Mrs. Bird, and we can help you locate that if that's something that you want to do to practice. This is a really good skill to practice. But with that said, I think that it would probably be to your benefit for if we at least went and looked at this problem right here. You do not have access to this problem, but what I would just suggest is maybe you, on your notes paper right now, that you just go ahead and write down these values, and then also that we are going to order these in ascending order. And so you're going to want to pause this video in order to do that, because I'm going to keep teaching, so that'll give you a chance to write it all down. Okay, so if we had to put these in ascending order, that means we're going to go from least to greatest. So we want to find the smallest number. And so we have to kind of figure out what these are all in decimal form. So if I look at the square root of 45, remember we want to find the square roots that it comes between. So the square root of 45, we don't know what that is, but we do know that the square root of 49 would be 7. And then if we went one less, that would be 36. And so 45 is kind of somewhere in the middle there, between the square root of 36 and the square root of 49. So we could just kind of do a little estimate and say, I mean, it's a little closer to the 7. I'm just going to do a little estimate that it's about 6.7. So I'm going to put 6.7 here. If you wanted to double check that, you could just do 6.7 times 6.7 and see if it comes out to about 45. Okay, and then our next number is 2 pi. Well, we know pi is 3.14, so we should do 3.14 multiplied by 2 to see about what that decimal value would be. 4 times 2 is 8. 2 times 1 is 2, and 3 times 2 would be 6. And remember, because the decimal's in 2 places, that's why it came in 2 places. So that one's about 6.28, which is a little bit smaller than 6.7, because if you need to, you can always put a 0 here on the end. 6.2 is smaller than 6.7. All right, and then we've got the 6 and 1/9, so we know it's going to be 6 point something. We kind of need to see what 1/9 is going to be. So let's chop down that 1/9 tree. So if we do 1 divided by 9, and these are going to have some work. You're going to have to go out to the side and do these calculations to convert these to decimals. Please make sure you're doing it without a calculator. 9 cannot go into 1, so we put a 0, a decimal, a 0. 9 can go into 10 one time. 1 left over, bring down a 0, and then 9 into 10 again. So it looks like it's just 0.11111. So it looks like this is 6.1 repeating. And then this last one is saying 2 times the square root of 9. Well, the square root of 9, that's easy. What times itself is 9? That's 3. So this is really just 2 times 3, which is 6. So this one is 6. So if we're going to put these in order from least to greatest, which one up here is the smallest number? It's going to be the 6, which is really the 2 square root of 9. Okay, and then, so I'm going to mark that one off so I don't get confused. And then the next largest one is going to be the 6.1 repeating, or the 6 and 1/9. And then 6.28, so 2 pi. And then the square root of 45. So whenever you're putting these in order, whether it's least to greatest or greatest to least, use the original number, not the decimal that you came up with. You're going to need to look at the decimal that you came up with right here, these red numbers, to see what order they go in. But when you write the actual values down, use the original ones. Now, it is interesting how they just kind of went reverse like that. That's not always going to happen, okay? Usually they're all mixed up, so just be careful. I hope that was a helpful example, and I hope this went well. Of course, as we're working through our virtual lessons and you're getting used to the new setup, we just ask that you would communicate with us if you have questions, to let us know how we can help you or to clear up any confusions that you may have. Please make sure you follow along in the steps, because after this lesson, now you have a 10-question quick check to do online in Schoology. So you're going to want to make sure that you do that. There's a deadline, so keep an eye on there. We're trying to keep things pretty simple for you and not give you too much. So please do a good job on this. This is a good opportunity for us to review some things we've done this year. Okay, we hope you're doing well, and we also hope to hear from you. So feel free to send us an email or check in just to let us know how you're doing. Thank you.